Everybody, Mrs. Bodechon here. We're going to do a lab where we go through a series of chemical reactions and we're going to look for those indicators along the way. So here is our lab setup, just so you can see how I kind of placed everything. We're going to go ahead and put some copper nitrate in the bottom of a test tube, and then we're going to go ahead and pour some sodium hydroxide right on top of that copper nitrate in the same test tube. I went ahead and I put the chemical equation up for you to look at and review. But if you can see, it just formed a solid precipitate. So it is kind of like almost a jelly consistency, and it's that deep blue color that you're seeing. See, when I turn it, it stays in its spot because it has turned into a solid now. So we're going to take it, we're going to put it into a beaker of some hot water, and we're going to let it do its thing. It's going to undergo another chemical reaction. I put the new chemical equation up on the board for you, and you can see that it is going to change colors. It's going to happen slowly at first. You can see little black specks starting to form in there, and this is in real time. I wanted to show it to you in real time at first, so you can see the blue is transitioning to that black color. And then once you kind of get the feel for this, I'm going to go ahead and speed it up. But just enjoy this color transformation for a minute. All right, you guys, so we're going to go ahead and speed this up a bit. Go ahead and watch now as it changes colors, which is one of our chemical indicators that we're looking for, from blue all the way to black. Check it out. Once it has all the way changed from blue to black, it's okay if some of the liquid in there is still blue, not a problem. Go ahead and cool it down. I cooled mine down for several minutes in just a room temperature beaker of water. I'm going to go ahead and put it back in my test tube tray, and now we're going to add some hydrochloric acid. I'm using 6 molar today, but you can use 1 molar. That's completely fine. You just may have to add a little bit more to it. And we're going to give it a stir with a stirring rod. And this is sped up a little bit, but you can see it is going to change from being that cloudy, black speckled, all the way to this very translucent, bluish, greenish color once it's all done. And I am continuing to add the 6 molar hydrochloric acid until all those little black specks are dissolved inside our solution. Okay, I also put up that chemical equation for you guys to look at as this is dissolving in. Next up, we're going to do another chemical reaction where we add a piece of aluminum foil. I'm just going to shove it down into the solution, and I put up the new chemical equation for that. Notice it ends in H2. H2 is a diatomic and it is a gas. So we are going to have gas evolution here in the form of those bubbles you see forming on the aluminum foil. That is actually hydrogen in the gas, in the bubbles. It is not air, okay? So that's pretty cool. You can also notice that our aluminum foil is starting to change color. Well, I'm going to pull it out of the test tube for a second so you can see it in just a minute once it's done with its color change. But it's actually going to start to turn this kind of like a deep reddish color. And that's because this is going to be a single replacement reaction. And here it is. I put it up on the screen for you to see. So the aluminum is actually being replaced with copper. So that red tint that has come out of the aluminum now is because the aluminum went in solution and the copper came out of solution. So you can see the copper is kind of all gathering right there, and it gives it that red tint. I hope this was helpful, you guys. Thank you for watching. Subscribe to see more. Bye, everybody.